Hi everybody, and welcome to the part 3 of our Algebra 2 practice final. We are just about done. Just in case you haven't seen part 1 or part 2, here's the instructions. Relatively straightforward, everything is free, all the links are free, the practice problems are free. Take the exam, check your answers. Whatever you got wrong, you can click on the timestamps in the description. It'll take you right to that question in my review, and I'll go over exactly how to answer that question. And there's extra practice problems in the description for every single question. Part 3 covers questions 17 through 24. So with that out of the way, let's go ahead and get started. So we get to figure out which of these patterns is geometric. And all I want you to remember with geometric series is that it just means to get to the next term, we have to multiply by the same value, what's called the common ratio. We're multiplying by that every single time. So right off the bat, I'm just going to take you to number 2 real quick. To get from 1 to 4, I need to multiply by 4. If this was geometric, I'd multiply by 4 again to get my next term, but 4 times 4 is 16. That's not what we get here. And then one more time, 9 times 4. That would give us 36. That's not what we have here. So 2, right off the bat, we know it's not that, or answer choice 2 as well. So it can't be number 2. Now, if you look at number 3, to go from 6 to 18, I have to multiply by 3. Okay, so all right, let's try that. 18 times 3 does not give us 30. So right off the bat, we know it can't be number 3. We have to multiply by the same value every single time to get to the next term. It's always going to be the same. So number 1 is not the prettiest, but I will show you, if it's not very obvious what you're multiplying by, all you need to do is take the next term, divide by the previous term. So negative 12 divided by 16. That simplifies to negative 3/4. Okay, so what I had to multiply 16 by to get to negative 12 was negative 3/4. Okay, and again, I'm going to repeat that because that's what you need to know how to do to get these weird fraction common ratios is take the previous term divided by, take the current term divided by the term that came right before that. That would give you the possible, if we don't know it's geometric, that could give you the possible ratio, and then we can test that. So if this is true, if this is geometric, then negative 12 times negative 3/4 should give us our next term. Now, if you do this, we can kind of negative 12 and 4, they cancel out to a negative 3. Negative 3 times negative 3 gives us a positive 9. So it works for that one. Now let's double check the last one. If this works, again, 9 times negative 3/4. This one doesn't cancel out very nicely, but we get negative 27 divided by 4. And that is, what is that? I can't even think of that off the top of my head. 13.5 divided by 2, what? 6.75, but negative 6.75. Hey, there we go. So that's what happened here. We had a weird common ratio. It wasn't so obvious, but again, geometric series means that to get to the next term, we're multiplying by the same exact value. In this case, it happened to be negative 3/4. And the last thing, if you don't know what it is, if it's not very obvious, take the previous term, or take the current term divided by the previous. And notice this would have worked with any of ours. If I had done 9 divided by negative 12, that would have simplified to negative 3/4. Okay, so that's how we do those ones, and our answer would be number 1. All right, we've got a system of 3 variables, which normally is really, really obnoxious sometimes, but really this kind of goes back to what you used to do in Algebra 1, where you had a system of equations where you had two linear equations. This one right here, well, now we have 3 variables. What I wanted to do in this case is let's take a look at these 2 right here. If I was to, let me move these over a bit. So I'm going to rewrite these. X plus y plus z equals 9. That's a 9. And then x minus y minus z equals negative 1. Our goal when we're solving these is to eliminate variables one by one. That's usually what you have to do, one by one, and then go back and plug in what you just found and then repeat. In this case, if I add these, just like you used to do back in Algebra 1, y minus y, that cancels right out. Z minus z, that cancels right out. X plus x, we get 2x. 9 minus 1, we get 8. So we get lucky in this case in that we didn't even have to do anything. These 2 equations, when we add them together, 2 of the variables automatically eliminate, and we just found a variable value, of a value of one of our variables. So we know x is equal to 4. So x is 4. We know that's part of the solution, so it's not going to be that one because we just found out 4 does work. Now what you do with this one is we have to go back and pick a separate set of equations. Because if we pick these same two and just plug in x equals 4, remember the y and the z are going to cancel right out. We're going to just be left with, nothing. It's not going to help. So I'm going to pick this one right here, these two. So let me write this out. X minus y minus z equals -1. X minus y plus z equals 21. And we know what x is, so I'm going to replace that with 4. We found out x was equal to 4. If I solve this a bit, and this is a z, by the way, my z's look like 2s. I apologize with that. It looks like -z plus z. They just cancel right out. Those are gone. So that's why I chose that, because they cancel right out. 4 plus 4 gives us 8. -y minus y, that's -2y, equals -1 plus 21 is +20. So now this just becomes a linear equation that we need to solve. Subtract 8 from both sides. And y divided by -2, y is equal to -6. Okay, so now we've got x, we've got y. Now we need to figure out what is z. So you can pick literally any one of these equations and just plug in those values that you just found. So I'm going to pick the easiest one. It looks like this is relatively nice. We found y was -6. Yes, it was -6. So if I plug it in here, it becomes a +6. So 10 minus z equals -1. I'm just going to add z and add 1, and we get 11 equals z. So z is equal to 11. That's also part of our solution. So -8 is the only one that's not part of this. Now, if you're not comfortable with what I just did, I'm going to put a link in the description, well, for all the problems, just so you guys can get some practice. But for 18 specifically, these systems of equations where we have 3 variables, it's not always going to be this easy. And if this wasn't easy, like, trust me, this was the easy version of this problem. It may take some practice. We may have to do something to one of these equations. Like, we may have to multiply both sides by something so that when we do add it to another one, our variables cancel out. It just so happened that I could add these up and they cancel out automatically. They eliminate. If you remember the elimination method, that's exactly what we just did here. But that was pretty much it for that one. So for 19, it's kind of testing how comfortable are you with your factoring of quadratics, but also with cubics. So what we're doing with this, what I want you to see for number 1, why that's not the answer, is x squared minus 1. That uses the difference of squares, which is something, if you don't remember, you definitely do need to remember that. A squared minus b squared is equal to a minus b times a plus b. If you look here, that would give us x minus 1 and x plus 1. That would mean we'd have not only a 0 of 1, but we'd have a 0 of -1 as well. So it can't be 1, so that's gone. Similarly, down here for number 3, and again, we're finding the zeros. That's why we're setting all these equal to 0. If I set this equal to 0, this right here, x squared would equal -25, right? And if I went ahead and tried to solve that by square rooting, I'd get the square root, that's a negative. I'd square root a negative number, so it'd be plus or minus 5, but remember, when we square root a negative, we have to put an I there. So there's no I there, that's why it can't be number 3. So it's not number 3. And now we're left with this and with this. Now I'm going to go ahead number 4 and show you, and then you can backtrack and double check your work for number 2 as well. To solve this, to factor these types of problems where you've got 4 terms and you've got a cubic going on. That's called factoring by grouping, where we just literally group the 2 terms, the first 2, and then the last 2. Make sure you include whatever the sign is in this second set of parentheses. And then we just factor out a common term. So x cubed and minus ax squared, they share an x squared. That's the largest factor they share in common. So that's an x minus a. And then -9x plus 9a, we're going to factor out a -9. And what we're left with, that just basically disappears off that. That becomes an x. That's a 9, by the way. And then when we pull off the -9, the positive becomes a negative, and we're still left with an a. The reason I pulled out a negative might not be so obvious, but if you pulled out a positive, this would be positive. The one thing about factoring by grouping is whatever you're left with inside the parentheses has to be the same. If they're not the same, you did something wrong. You have to go back and double check. And 95% of the time, it's just I forgot to pull out a negative, or I did pull out when I shouldn't pull out a negative, something like that. But here's where we go from here. I pulled out a negative. Sorry, there we go. So once you have this, really, you can look at these 2 expressions, this and this. They both share an x minus a in common. So if I factor out an x minus a from both of those, this becomes an x squared, and this becomes a -9. Now, if you look, if that's equal to 0, x minus a equals 0. Okay, so a is of 0. Now, x squared minus 9, that looks exactly like the difference of squares that I showed you before, which you definitely have to remember. That's back from Algebra 1, but it kind of randomly, you just forget about it. X squared minus 9 simplifies to x minus 3 and x plus 3. And if we solve both of those for 0, we would get a plus and a minus 3. So that's why it's number 4. Now, again, with this factoring by grouping, which again is something you definitely need to know, you can check this and see why this is not correct by doing factoring by grouping and seeing what you get for that. But I'll leave that up to you. Number 4 is our correct answer for this one. So it looks like here we need to solve this equation and write it in, if we wrote it in this simplest form of a complex number, we need to find out what the value of b is. So basically what number is attached to the I. Now, in this case, what I'll tell you is that if we distribute, and all this should be relatively straightforward at this point, 5x squared, we need to solve this. We've got a quadratic. I'm going to get everything on one side, minus 4x plus 2 equals 0. And that's just me subtracting this and adding this. It doesn't look like to me that this one would factor, so we get to use that awesome quadratic formula that everybody should hopefully remember. Negative b plus or minus, and we'll write this out up here just so you remember. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's normally as x equals that, right? Or whatever our variable is. So in this case, negative b gives us negative 4, so positive 4, plus or minus the square root of b squared, so that's the positive 16, minus 4ac, so 4 times 5 times 2, that's 40, all over 2a, so 2 times 5. So 16 minus 40, that gives us a negative 24. And what we're going to do from here is we're going to have to simplify this. So I'm going to go right ahead and pull out the I. If you remember, if you have a square root of a negative number, you can pull out the negative as long as you put an I out front. That's a really simplified version of it. Remember, the square root, I is equal to the square root of negative 1. So that's why we can do that. Now, can we simplify the square root of 24? That happens to be, and just if you're not comfortable with that, that's the square root of 6 times the square root of 4. Square root of 4 is just 2. So we can put the 2 out front. Let me move this over, put the 2 right in front. So we get 2. Usually we put the I after any other number. We get this good looking problem here. I can't write everything or copy. There we go. Nope, missed it again. Okay, one more time. There we go. All right, this right here. So we get 4, if we break it up, 4 over 10 plus or minus, now 2 over 10, we can simplify this to 2 over 5. I forgot about that. 2 over 5, 2 over 10, that just simplifies to 1 over 5. So I'm going to put this as, this next part as 1, which I don't have to write because it's basically an invisible 1 over 5. Now, if you look, this looks exactly like what they were telling us up here, a plus bi form. If you look, we've got a, I know there's a minus here, but don't worry about that. This plus something times I. What's multiplying our I value? It happens to be this root 6 over 4. Okay, that's where root 6, I said 4, I meant 5. Root 6 over 5. Did I write a 4? No, I just said it completely wrong. Root 6 over 5, that's where we get that one. So we had to do a little bit of the quadratic formula, which doesn't go away after Algebra 1, I promise. It actually comes in handy. And then just figure out what number is attached to the I, what coefficient is attached to the I. And that's it for that one. All right, so we're being asked to find the smallest solution where this function is equal to this function. Now, obviously, we're going to need a calculator for this one. There's 2 ways we can do this. You can either, well, you can plug both of these into their own if you're using like a TI-84 or something like that, or 83 or what have you. You could plug in your y1 is equal to either one of these, plug in the other one as y2, and then graph them. And you'll be able to see where they intersect. I actually plotted them here. You'll be able to see where they intersect. Notice they intersect at multiple points here, here, here. Your graph actually has, I believe, an intersection. Your graph, I meant your calculator. Your calculator should have an intersection. What is it called? Button? No, intersection capability. I can't think of words. I can't talk. But should have the ability to find the intersection of 2 functions where you kind of plug them in and pick, where is it to the left, where is it to the right, and then guess. In this case, we can actually give it the eye test. If you look, again, x cubed is going to never come back up. It's always going to go down forever. So this is the farthest left that they're going to intersect, and it looks almost exactly like it's at -2. So that looks like the smallest solution where these two functions are equal to each other, which is exactly what they're asking us right here. And this looks like -2 and change. If there was something else more specific, like -2.05, then we'd have to actually set them equal to each other on your calculator, do the intersection thing, and go from there. Of course, as we reach the end of this, the multiple choice part of this exam, they throw some more complex numbers at us, imaginary numbers. So it looks to me like the first thing that we have to do is we've got some foiling that we need to do. So if I go ahead and write this out, x that plus this, that's an I, and then FOIL is out, I get x squared. Well, actually, I put that's both. They're both minus. What am I doing? I'm thinking of difference of squares from a couple questions ago. I wish it was difference of squares, but it's not. So minus 2ix minus another 2ix. So that's minus 4ix, and then plus. Here's the important part: plus 4i squared. Remember, I squared is equal to -1. So if I simplify this, that's just minus 4. Okay, and then everything else kind of just falls into place. I need to just kind of write everything else out. It's not going to be very pretty, but just bear with me. 7 minus 3i. We just did this. There's plus that. All that minus. Now we want to make sure you distribute the negative. I can't tell you how many times I've seen students in every class, calculus included, forget to distribute that. So minus 4i minus 2x squared. Now we get to combine like terms. So I see x squared. And basically, everything that has an I, we want to combine together. Everything that does not have an I, we want to get by itself. So I see a -3i, I see a minus 4ix, and I see a minus 4i. So that right there, the i's, the ones that have just an I in them, we can combine those two together. So these two combine to give us -7i, and we've still got a minus 4ix. So what we want to do with that is we want to actually factor out, and we can put these other ones here. So what, 7x squared, -4, -2x squared. So whoops, that's paintbrush mode, not that. So x squared and -2x squared, those give us a minus x squared. And then 7 minus 4 gives us a plus 3. Now here, again, we don't want to leave it like this. We want to write it in a plus bi form. So that's why what I was saying, we want to take this and factor out an I. So if I take that, we get -x squared plus 3. And then, let's see, we factored out. We could, I guess, pull out a negative. If I pull out a negative I, we get 7 plus 4x. And let's see if we can zoom out just a bit. If that works up here, we get, and this -x plus 3 is just 3 minus, or -x squared plus 3 is just 3 minus x squared. So it couldn't be that. Couldn't be that. I see 3 minus x squared. I see 3 minus x squared. But we know there's a bunch of i's going on, more than just a minus 7i. Okay. It's a 4x plus 7. So there was this guy right here that had an x attached to it. That's where this x comes from. Okay. So factored out the negative, and we get our final answer for that. And that's pretty much it for that one. It's just really distributing a bunch of stuff, being comfortable. I guarantee a bunch of people are going to get this I squared wrong, because I squared is -1. Everybody forgets that. Just make sure you're comfortable when they write it like this. They want you to combine all the I terms together, factor out the I, so that we can have it like this, because that's what they asked us to do. Okay. All right, so we're given some weird looking rational equation, rational expression, and we want to write it in simplest form. Okay, and they tell us this because that would make this equal to 0, so we have to have that there. But for our purposes, it looks like we're just going to look at the numerator and the denominator, and let's just factor those. So at the top, it looks like I can pull out an x. I would get x squared minus 9. Now, if you've been doing this whole final review with me, I guarantee you've heard me hear say difference of squares multiple times. That's a dead giveaway right here. There's a difference of squares going on right there. Now, for the bottom, 9 minus x squared. Again, does that look like we could use difference of squares? I hope you said yes, because we definitely can on that one. So let's do the first one, the top one first. So x squared minus 9, that just simplifies to x minus 3 and x plus 3. And again, that's your difference of squares. If you're not comfortable where I got that, check it out. It's something you definitely need to know. It's a shortcut for factoring these simple quadratic looking things where there's two terms subtracted together. This is also a difference of squares because it's 3 squared minus x squared. So this would factor to 3 minus x times 3 plus x. Now, it's tempting to be like, all right, well, nothing cancels, like, you know, or except for this x plus 3. Sorry, what was I kidding? X plus 3, 3 plus x, literally the same thing. But from there, it looks like, all right, well, that's about all we can do. Those are not the same. But one thing I want you guys to remember that you probably haven't seen in a while, there's one property where if I get, and I can't even think of it for the life of me, but I use it all the time, a minus b is equal to b minus a, but negative. The opposite. So I could write either one of these. I'm going to take the bottom equation, and this is the same thing as writing x minus 3, but negative. Okay, so that's 3 minus x is the same thing as writing this. Okay, now if you look, hey, those cancel out. We've got an x over a negative 1, so I'm just going to, you know, put that x or the negative on the x. That's all we're left with. There's literally nothing else there. We've got this, that's gone, everything's gone except for the negative that I put on the x. That's where that goes. Okay, so really, this is purely just a difference of squares, and then this, if I subtract two values in the opposite direction, I get the opposite sign of them. Kind of, I can't remember the property, but that's something that you need to remember because you will use it again. So the last one here, it looks like we've got 45% of Americans with type O blood, and they have a number generator that produces these 3-digit values that go from here to here. Now, first things first, this 45%, we're going to use that in a second. I want you to know the main problem with this that they're trying to test you on is how comfortable are you with your counting, right? A lot of people are going to be like, oh, well, there's 999 values in here, but you've got to count 0. So every time we count, like from 0 to 10, we think, oh, well, that's 10. But if you include 0, that gives us 11 values. So even though we're not at 1,000, we have to add 1 to it to find the total number of values that we could generate because we're including 0, okay? So there's 1,000 total possible values. 45% of those values are type O, and that's what we want to know. Which of these 3-digit values could represent type O? So we take 45%, represented as a decimal, multiply it by 1,000. That'll tell us how many are type O. 450. Now right here, I guarantee you, I don't know how many are going to, I don't know percentage, but a high percentage are going to say, hey, it's got to be number 4. I got 450. But remember, one of those 450 is represented by 000 that we don't include. So we need to subtract because that's just the total number. But one of those is from 000 to 449. So 000 to 449 inclusive because it could be this and any value in between and including this. That's our 450 values that we get. Okay, so that would be number 3. And of course, they throw this tricky question at the very end of the multiple choice, but that's all they're asking for there. Oh, and we are done with our Algebra 2 practice final. Congratulations. Make sure you like, subscribe, and share this video to help others. Hopefully it gave you a little idea of what you need to look at, maybe any topics that you need a little bit more practice with. But until next time, best of luck with your studies.